So now students, we will go ahead with our chapter on chemical reactions and equations. In the previous lecture, we learnt about two different types of reaction, that is combination reaction and decomposition reaction. In today's lecture, we will learn about another type of reaction called the displacement reaction and a double displacement reaction. Now, before we learn about displacement reaction, let us revise some terms which are very important to these types of reactions. You will come across terms like ions, IONS, right? So we need to understand about ions and the relation in these types of reaction, that is displacement or double displacement reaction, because basically in displacement and double displacement reaction there is an exchange of ions or displacement of an ion. So let us understand what is an ion. Now students, an ion is a charged atom, right? Now what is a charged atom? An atom that loses an electron or an atom that gains an electron is called as an ion. The moment an atom loses an electron or gains an electron, it no longer remains an atom. It becomes either a positively charged ion if it loses electrons, or it becomes a negatively charged ion if it gains electrons. Now students, let us understand the big difference between metallic atoms and non-metallic atoms with respect to formation of ions. Students, metals normally have a tendency to lose electrons, right? Because normally you will find in metallic atoms there would be 1, 2 or 3 electrons in their outermost orbit. In general, metallic atoms have a tendency to lose electrons and form positive ions, right? Now positive ions, all of you know, are called as cations because they get attracted towards the negatively charged cathode, right? So metallic atoms have a tendency to lose electrons and form positive ions. On the other hand, non-metallic atoms have a tendency of gaining electrons and forming negatively charged ions. We also call negatively charged ions as anions as they get attracted towards the positively charged electrode called the anode, right? So all these are basically revisions of concepts which you have learned in the 8th and the 9th, and probably some of you may not remember them. So to gain a better understanding of displacement and double displacement, I had to revise this, right? Now displacement reactions take place in both metallic compounds and non-metallic compounds as well, right? In metallic compounds you will have one positive ion joined with a group of negative ions, right? So let's say you have a compound called copper sulfate. Now I told you copper is a metal, sulfate means sulfur and oxygen, they are groups of non-metals. So copper being a metal is a positive ion, and sulfur and oxygen, that is sulfate group, will become a negative ion. You also learnt about radicals. Radicals again are nothing but atoms or group of atoms that give up electrons or lose electrons. So these are radicals. Now let's not go into detail about that, but normally in a compound you will have a positive ion and a negative ion. that comes together to form a compound in mostly ionic compounds. You'll have a positive ion and a negative ion bonding together to form compounds. Now in metallic compounds, obviously the metals are positive ions, because I told you metals have a tendency to form positive ions by losing electrons. So in a metallic compound like copper sulfate, we have copper as the positive ion and sulfate, which is a group of sulfur, single sulfur atom and 4 oxygen atoms, right? SO4. So they are negative ions, or a group of ions having a negative charge, you call them as radicals, right? So in copper sulfate you have copper ion, which is positively charged, and the sulfate ion, that is negatively charged, right? We'll see how a displacement reaction takes place when a compound like copper sulfate is made to react with zinc. In the earlier reactions, we were talking about some examples. We saw that copper sulfate was reacting with zinc dust. Zinc dust was put in a copper sulfate solution. We studied in one of the examples, and we saw that zinc, on reacting with copper sulfate, formed zinc sulfate and copper. That means copper sulfate got displaced from its solution by zinc, and it led to the formation of zinc sulfate, right? So basically, students, what happens in such a type of reaction, we will see when we go in detail. Basically, in a displacement reaction, a more reactive element displaces a less reactive element from its compound by formation of its own ions. We will see when we explain again the reaction of copper sulfate and zinc in the context of a displacement reaction. What we are learning is a single displacement reaction. Of course, we will learn what is a double displacement reaction. But in a displacement or single displacement reaction, a more reactive element, when I say element, I refer to metals, non-metals, everything, okay? Because displacement reactions can occur with metallic compounds and non-metallic compounds, but here we are giving you examples of lot of metallic compounds, right? So a displacement reaction is a reaction in which a more reactive element, like let's say zinc, displaces a less reactive element like copper from its compound. What is the compound? Copper sulfate. So copper gets displaced from its compound copper sulfate by zinc, because zinc forms a positive ion and copper becomes an atom again, because zinc probably has given copper its electron. So copper gains electrons and gets converted back into an atom. From a positive ion, it gains electron and forms a atom again. So this is what happens basically in the displacement reaction. Even when you come to the chapter on metals and non-metals, you will learn the reactivity series of metals, right? Sodium, potassium are very highly reactive metals. Gold, silver at the bottom of the series are less reactive metals. When you learn in the reactive series, you will see that zinc, iron, lead, magnesium, they are all placed above copper in the series, which means that these metals are more reactive than copper. And that is why whenever you combine or you make the more reactive metals react with a compound of a less reactive metal, then the more reactive metal displaces the less reactive metal from its compound by formation of ions itself, and the less reactive metal becomes or gets reconverted into an atom. So let us look at the examples on the board. You will be able to understand a displacement reaction better. When I say displacement, right now I am referring to a single displacement reaction. So here we have the definition of a displacement reaction. The reaction in which the place of the ion of a less reactive element is taken by another more reactive element by formation of its own ions is called a displacement reaction. Now students, in the first example here you can see you have a metallic compound, copper sulfate, right? Now copper sulfate compound is formed by the combination of a copper positive ion, because during the formation of this compound copper lost electron to form a positive ion. Sulfur and oxygen together as a group, they gained the electron lost by copper and became negatively charged. So both of them combined together because of their opposite charges and formed copper sulfate. So in copper sulfate compound you have a positive ion and a negative ion in this sulfate group. The sulfate group is a negative charged ion. Now what happens when zinc is put in an aqueous solution? This is aqueous solution, right? Aqueous, I told you, whenever you have something dissolved in water as a solvent, it's called an aqueous solution. When zinc dust is made to react with the copper sulfate solution, that means you take copper sulfate blue color solution in a beaker and put some amount of zinc dust in that. Immediately zinc being more reactive than copper. Now zinc is a more reactive metal than the metal copper, so zinc immediately displaces copper. Now the only way that zinc would displace copper is zinc would donate the electron which is less in the copper atom. So copper will accept that electron and it gets reconverted into a copper atom, which you can see here, copper solid being formed. So what happens in this reaction? A more reactive element zinc displaces a less reactive element copper from its compound by formation of its own ion. That means if zinc is going to get attached over here, this being negative, zinc will have to form a positive ion. When zinc forms a positive ion, how will it form? It will form the positive ion by donating an electron to copper. So zinc becomes a positive ion by losing electron and copper gets reconverted into an atom when it accepts that electron which was less, right? So then you have the formation of zinc sulfate, because zinc has taken the place of copper in the copper sulfate and forming zinc sulfate. You can see zinc is the positive ion now and sulfate is the negative ion, and copper over here, which was originally a positive ion, gets reconverted into an atom. An atom is formed when the electron that it earlier lost is again gained. So a positive ion, when it gains a lost electron, then it gets reconverted into an atom. So this is basically the technique by which a single displacement reaction takes place. Now please, I repeat once again, students, in a displacement reaction, that is a single displacement reaction, what happens is that the place of a less reactive ion in a compound. So the less reactive element is copper. So the place of a less reactive element is taken by the place of a more reactive element, that is zinc, by formation of its own ion, right? Thereby displacing copper. So copper has got displaced from its compound. That's why we call this as a displacement reaction. It is not only that zinc can displace copper. I told you that there is a reactivity series of metals, starting with potassium, then sodium at the top, and then coming downwards to silver and gold being less reactive or almost not reactive. You know, silver and gold, platinum, they are called as, especially gold and platinum are called as noble metals because they don't react. So they are at the bottom of the series. Copper is still down, but above copper you will find magnesium, you will find iron, you will find zinc. They are more reactive than copper. So you can see in the next two examples, even if iron is made to react, if you take few iron particles, dust, and put it in a copper sulfate solution, iron being more reactive will displace copper positive ion from the solution, that is copper sulfate, and copper forms an atom, and iron joins up with this sulfate to form iron sulfate solution, aqueous solution. So this copper, you will find that either it will get deposited on the iron. I will show you an example. I will send you a video showing you how iron displaces copper from its solution. You will find the iron nails being dipped in the solution of copper sulfate. When the iron nails are dipped in the solution of copper sulfate, then this iron displaces copper, and copper gets deposited on the iron nail, making it brownish or reddish brown in color. The reddish brown color is the coating of copper which gets displaced, right? I am going to send you that video along with this lecture. So let's look at the other example. You can see here lead also plays. Lead is the more active metal as compared to copper. So lead displaces copper from its compound, that is copper sulfate. Copper gets removed, lead takes its place and forms lead sulfate, and copper gets deposited on the surface of lead, right? So this is how displacement reactions take place. So displacement reaction, I hope students you have understood. We will now go on to a double displacement reaction and see how different a double displacement reaction is from the displacement reaction. Let's have a look at the double displacement reaction. What you saw earlier was a displacement reaction, which you can also refer to as a single displacement reaction. Now let's see how it is different from the double displacement reaction, right? So the reaction in which the ions in the reactants, here you have two reactants, are exchanged to form a precipitate. Precipitate means residue, is called a double displacement reaction. I repeat once again, the reaction in which the ions in the reactants are exchanged to form a precipitate is called a double displacement reaction. Now see here, you have two compounds. Now if you look very closely, you have silver nitrate and sodium chloride, right? What is peculiar about this is both are metallic compounds. Both are metallic. Silver is a metal, sodium is a metal. Both are metallic compounds. Now, in both these, when both these metallic compounds are made to react with each other, see here you have a test tube A in which there is a mixture of silver nitrate and sodium chloride. We had seen this reaction when we were explaining chemical equations, right? So you have this test tube in which you have an aqueous solution of silver nitrate mixed with a aqueous solution of sodium chloride, that is salt water, common salt water, right? So when they are mixed together and stirred, or when the test tube is shaken, then a reaction takes place leading to the formation of sodium nitrate and silver chloride. This is indicating precipitate. Precipitate, you can see, is silver chloride becomes insoluble in this solution, and because it is insoluble, a whitish color powder, here of course I have done it black in order to show you this precipitate, but here a whitish color powder of silver chloride is formed. So what happens in a double displacement reaction? A more reactive atom in its compound, sodium, remember, is more reactive than silver. So sodium displaces silver from silver nitrate, and sodium takes its place forming sodium nitrate, and silver combines with chloride to form silver chloride. So sodium, being more reactive metal, pushes out silver from its compound and takes the place of silver. Silver combines with chlorine to form a precipitate of silver chloride, which is not soluble in that solution. That's why it forms a precipitate. Remember, if you can be asked, a precipitate is formed in which type of a reaction? So please remember, it is a double displacement reaction in which a precipitate is formed due to exchange of ions. You can see here what happens. Sodium comes here and silver goes here. So that's how you get sodium nitrate and silver chloride precipitate. So this is a very good example of a double displacement reaction where there is an exchange of ions between the reactants leading to the formation of a precipitate, right? So this is an example of a double displacement reaction. Students, is this equation a balanced equation? Just have a look at it and see whether it's a balanced equation. Have you counted the atoms on the reactant side of each element? Silver here, silver there. How many atoms are there of each element of nitrogen? This is N is nitrogen, O is oxygen. Nitrate. Okay, here. So by now you would have counted, if you have counted it correctly, you will find that the number of atoms of each of these elements on the left hand side is the same as the number of the atoms of those elements on the right hand side, right? So the number of atoms of each element over here on the reactant side is the same as the number of atoms of those very same elements on the product side. So it's an example of a balanced chemical equation. So I hope, students, you have now understood even the double displacement reaction. So students, you have now today learned what is a displacement and a double displacement reaction. Go thoroughly to the explanation, through the explanation properly. Practice them all over and over again, right? Prepare thoroughly whatever has been taught in this chapter till now. In tomorrow's lecture, we'll move ahead by understanding more about exothermic reactions, endothermic reactions. Then we have oxidation reactions, reduction reaction, redox reactions to be carried on. So in the next 4 or 5 lectures, we should go through with this chapter. But each and every topic being taught right now, even today's topic was quite important. You need to understand that precipitate is formed in a double displacement reaction. It's a very frequently asked questions to trick the students. So please remember now till the end, till you have your board exams, you have to remember that a precipitate is formed in which reaction? Is it a displacement or a double displacement reaction? Precipitates are formed only in a double displacement reaction. What is a precipitate? It's something that becomes insoluble and settles at the bottom of a flask or a test tube. It may be in the form of a powder or a solid, right? So students, with this I conclude my today's lecture. So we see you during the next lecture, maybe on endothermic and exothermic reaction. Till then, students, take care, stay safe and do your work regularly. We will definitely meet in a short period of time. Things will get over and probably the situation will turn better. Till then, students, thank you all of you and bye to all of you.